Hey guys, welcome back to today's video. We're going to start part 2 of the RF6-7 outcome, more specifically for the slope-intercept form. If you haven't had a chance to watch part 1 yet of slope-intercept form, please go ahead and click the link up here. It'll take you right to that video. So let's get started. So the first thing that we're going to talk about today is how to actually graph slope-intercept form. So I just want to outline some of the steps that we need to take in order to graph slope-intercept form. Once again, it's y is equal to mx plus b. In the previous lesson, we talked about what m and b represent in that linear equation. We talked about how m represents your slope. That's a quick review. And that b represents your y-intercept. So for us here, we're going to start. Once we've done that step, we want to make sure that we understand exactly where that y-intercept goes. So again, if I were to quickly draw a little sketch here, your y-intercept is the point where your graph crosses that y-axis. So in our little example here, we'd have our y-intercept be right over here where that blue dot is. So that's always going to be our first step. Start by plotting the y-intercept if possible. We're going to talk about some other alternatives later on. If you aren't given the y-intercept, you can just use a different point. And then after that, we're going to go ahead, we're going to use the slope to plot one or two points to the right of the y-intercept, and then 1 or 2 points to the left. So what that's essentially going to look like is, if I have an example here, so just from the start, I'm going to go ahead and plot my imaginary y-intercept. So let's say we're starting down here, and if we know that your slope is 2 over 3, essentially what I want to do is I want to go up 2 units and then 1, 2, 3 to the right. So I'd have another point maybe somewhere over here. I'm going to go up another 2, 1, 2, and then 1, 2, 3 to the right. So I'd end up with something like that. Now, if I were to extend this towards the left of my y-intercept here at this point, I would have to do the same thing, except instead of going 2 up, I will move 2 down. And instead of moving 3 to the right, I'm going to move 3 to the left. So what that'll look like is, from my y-intercept here, I'll move 1, 2 units down, and then 1, 2, 3 units to my left. So I'll end up with another point roughly about there. And then you guys want to make sure that you're using a straight edge, like a ruler, to connect all of your points. I'll go ahead and do that with a line that I have here. All right, so those are essentially your steps for making sure that you understand how to start graphing slope-intercept form. We're going to try a couple of examples out together. You guys will also notice some extra practice problems located at the top right of your screen that you can find in your textbooks that are located on D2L. So over here, we've got 4 examples of us graphing slope-intercept form when we're given the equation. So again, we're going to first identify your slope and your y-intercept with each given equation. So in example number 1, we've got y is equal to 2x minus 4. Our first step is to identify that our slope here is going to be 2 because we're looking at the coefficient beside the x. And then we're going to recognize that your y-intercept, your b value, is negative 4. So please do not forget that negative. Super important. It's a mistake I see students make all the time. They forget about that little negative. Make sure that's included with in your b value. So we're going to go ahead and plot that negative 4 down on this graph. So we're looking here, we're starting at your origin. And we're going to move down 1, 2, 3, 4 to negative 4. So that's where my first point will be. And we're going to go back and refer to my slope. So my slope is a positive 2, which means that for every 2 units that I move up, I'm going to move 1 unit to the right. So I could technically rewrite my slope as 2 over 1. So I move 2 units up and then 1 unit to the right. So I'm going to go ahead, 1, 2 units up, and then 1 unit to the right. So my next point goes right there. I'm going to go 1, 2 units up, 1 to the right. And I'll continue to do so until I've got a nice line going. And I'm going to go ahead and connect those points here with a straight line. All right, so that's example number 1. Example number 2 over here in the top right, we've got an equation y is equal to negative x plus 3. So let's go ahead and identify, first of all, your slope. So your slope in this case, it's going to be the number beside the x. We don't see it, but it's actually a negative 1. So we could interpret that as a negative 1x. So we've got negative 1. And then we're going to look at your b value. In this case, it's going to be a positive 3. So let's go ahead and write down a 3 there. So from here, we know that since your b value is a positive 3, we have a point at 0, 3. Okay, so we're going to start off at the origin. We know that 0, 3 is going to be right here. We're going to go ahead and plot that first point. So since your slope is negative 1, that means we could rewrite your slope as negative 1 over 1. It means that for every 1 unit you move down, you're going to move 1 unit to the right. So we're going to move 1 down, 1 to the right, and plot our first point to the right there. We're going to move 1 down, 1 to the right, and we're going to continue to do so for a few more points. Now, to the left of my y-intercept here, let me clean that up a little bit. You want to make sure that we're doing the opposite if we're moving towards the left. So if we're moving towards the left here, instead of moving down, we're actually going to move up. So we're going to do the opposite. So instead of going 1 down, 1 to the right, we're going to instead go 1 up and 1 to the left. So we're going to go 1 up, 1 to the left to give me a point there, and then 1 up, 1 to the left to give me my last point there. And I can go ahead and link or connect all of those points with a nice straight line. So it'd look something like this. All right, example number 3, we've got y is equal to 1/3 x plus 2. So we're starting to look at some fractions now for our slope. So to start us off, we know that y is equal to 1/3 x. So our slope is going to be positive 1/3. And then we have a b value of positive 2, which means that our y-intercept is at the point 0, 2, or has the ordered pair 0, 2. So let's go ahead and plot that point right over here. So 0, 2. Now our slope, since it's 1/3, it means that for every 1 unit we're moving up, we're going to move 3 to the right. So starting off at your y-intercept, move up 1 and then 3 to the right for our second point. We've run out of room going towards the right, so we're going to go and look at going towards the left here. So we're going to go look at our y-intercept. We're going to go 1, 2, whoops, sorry. So starting from your y-intercept, instead of moving 1 up, we're going to move 1 down. And then instead of moving 3 to the right, we're going to go 3 to the left, which gives me another point over here. And, oh, I realize you guys can't see it here. So we're going to end up having a point here, and then a point right there, like so. Just having some technical difficulties here. And then we can go ahead and connect all of those with a nice straight line. Okay, in your final example here, we have a slope of negative 2 over 3x, and then minus 1. So we've got a negative 2/3 will give me my slope. And then we'll have a b value of negative 1. So again, really important to remember that you don't forget that negative 1 there. So my slope is negative 2/3. And my slope, or my b value, is negative 1, which means that I have a point at 0, negative 1. So I can go ahead and plot my first point at my y-intercept. So it's my y-intercept here. So it's at 0, negative 1, which is right down here. And then we're going to go ahead and look at my slope. So since our slope is negative 2/3, it means that for every 2 that we go down, we're going to move 3 to the right. So we're going to move 2 down, 1, 2, and then 1, 2, 3 to the right. We're going to have a point right here. Let's do that in red. And we've run out of room going towards the right. So we're going to start back at my y-intercept. I want to move 2 up and then go 3 to the left here. 2 up and 3 to the left. And then we can connect that with a nice straight line. So we'll end up with a result that kind of looks like that. So now we're going to start to talk about how to manipulate some sort of linear equation with the form of y is equal to mx plus b. And this is generally where a lot of students tend to struggle with the algebraic portion, just because students are a little uncomfortable understanding how to move a variable from one side to another, how to isolate variables. So I've actually gone and created a quick review video. If you click the link that pops up on your screen, it'll take you straight to the video and you can take a peek at it and see if that helps you out. So there's going to be a couple different scenarios where we're going to be asked to find the linear equation in slope-intercept form. All right, so the first scenario is if we're given a y-intercept, a point on the line, and no slope. So that means that here we're going to be given a b value. A point on the line means we're going to be given x and y. And we don't know what slope is. So it's a big question mark for us. Okay. The second scenario is if we're given the slope. So we do know what m is in this case. Oh, that is not lining up very well. We are given the slope. We're given a point on the line, so we know x, y, but we don't know what b is equal to. And then last but not least, we might be given a slope, a y-intercept, and asked to find a point on the line. So if we're given the slope, means that we're given m, we're given a y-intercept b, and we want to find out what another point on the line could possibly be. So there's a couple different scenarios we're going to work through here. So scenario one, we're given the y-intercept and a point on the line. So our example gives us a y-intercept of 0, 3 and a 0.54. So for us, if we're looking at our b value, okay, your b value for in this case is going to be 3. So it's going to be pulled straight from your point that's given there. So we've got 3 as our value. So I've got an x value of positive 5. And then I've got a y value of positive 4. So I can go ahead and put those two values in. Oh, let's clean that up a little bit. At a value of 5 and then a value of 4 there. So you want to substitute those values into slope-intercept form. So right away we can see that the y actually comes down over here. The x is going to come over here. And then your slope, or rather your y-intercept, is going to come over here. So let's go ahead and fill in each of those values. So we got 4, 5, and 3. So we've got 4 is equal to 5m plus 3. So we're going to have to work backwards to solve for m, or rather to isolate for m. So what we need to do here is we're going to try to get that 5m by itself. So we have a 5m plus 3 right now. So in order to get rid of the plus 3, our first step is to actually subtract 3 from both sides. So we're going to have subtract 3 from the right side and then subtract 3 from the left side. So we are left with 1 on the left side is equal to 5m. Now to get the m by itself, recall that 5m is the same thing as 5 times m. So instead of multiplying by m, we're going to do the opposite, and we are going to divide both sides by m. So we'll have 1/5 is equal to m. So that means that in this case, your slope is actually equal to 1/5. So the final equation that we'd need, and again, this is another point or another part where students get a little confused. They ask me, why don't we put the x and the y back into my slope-intercept form? Well, the reason why we don't do anything with x and y after we've solved for a particular value or variable is because the x and y generally represent a general value. We can plug in an x value once we know the slope, once we know the b value. We can figure out what the y looks like. Okay, so we've got y is equal to, like we found, 1/5x plus 3. So y is equal to 1/5 x plus 3. So again, the question that gets asked often is, why don't we do anything with x and the y? Why don't we put the 5 and the 4 back into here? Well, we don't need to do that anymore. What this linear equation does is it gives us the opportunity to input an x value. So once we've got 1/5, for example, 1/5 times 1 plus 3, we can figure out what the y value is. On the inverse side, we can figure out, okay, if y we know is 3, then we can figure out what the x value is because we know everything else in this equation. Okay. An alternative method we could also use is using the slope formula and use the y-intercept to find the equation. So we can pop that over really quickly. So since we know m is equal to y2 minus y1 over x2 minus x1, and we were given 2.03 and 5.4, we can go ahead and plug those values straight into here in order to find what my slope is. So again, if I were to label these as x1, y1, x2, y2, let's go x1, y1, x2, y2, I can go ahead and substitute in my values there. So this would be 4 minus 3 over 5 minus 0. So this would give me a slope of 1/5. Okay, so that's an alternative method to figure out that scenario. In this scenario, if we're given the slope and a point on the line, we want to try to figure out what b is equal to. So once again, let's go ahead and identify what each of my variables are. So m in this case, again, represents my slope. That's right there. We know my slope is going to be 4. We know that our point -1, 2 will give me my x and my y values. So I know that x is going to be my -1, and I know that 2 will be my y value. And once we've got all of those values, we're going to plug them into slope-intercept form. This y value of 2 has to come down over here. My slope and my x values have to come into these positions. So we've got 2 is equal to 4 times -1 plus b. Now we need to work backwards to solve for b. At this point, we're going to end up with 2 is equal to -4. So that -4 comes from the 4 times the -1 plus b. You want to get that b value by itself. So we have a -4 here. In order to move that -4 or to move it away from that b value, we want to add 4 to both the left and the right sides. So we're going to add 4 and add 4. We are left with +6 on the left side, and we have b on the right side. So we know that b is now equal to 6. We're going to go ahead and plug in that b value into that original equation. And we've got y is equal to 4x plus 6. So now we're given our third situation where we have the slope and we have a y-intercept, and we need to find another point on the line. So in this scenario, if we're given an example where our slope is -3 and our y-intercept is at 0, 4, means that we'll end up having an m value of -3, and our b value is 4. Right away, we know that our equation is going to end up being y is equal to, let me move that down a little bit, y is equal to -3x plus 4. So all we need to do really is we need to find a value for x, so we can pick any x value. Okay, now this is what I talked about in one of the previous slides, where if we pick a value of x, we can figure out what our y value is. If we want to plug in a value of y, we can figure out what the x value is. So let's choose a value that's really straightforward for us to figure out. Let's choose if x is equal to 1. So it doesn't matter what point you choose. I could choose 0. I could use 1. I'm not going to use 0, and I want you guys to figure out why. Why wouldn't I use 0 in this case? Okay, so I'm going to use 1 just to keep things simple. Let's go y is equal to -3 times 1 plus 4. Y is equal to -3 plus 4. And y is equal to positive 1. So when x is 1, y is also equal to 1. So another point on this line would end up being 1, 1. That's it for today's video. In the next lesson, we're going to talk about point-slope form, so stay tuned for that. If you haven't already subscribed, make sure you do so you get a notification as soon as the new content comes out. See you in the next one.